Hi students! It's been a long time! Welcome back to Maestrang Techie YouTube channel, another video lesson about Grade 9 Science Quarter 2. Quarter 2 is about chemistry. Interesting, right? Week 1 lesson is all about the quantum mechanical model. In this video, I will show to you the history of how atoms are developed throughout the years. Here are our learning objectives. Identify the development of history of atom. Give the importance of the development of atom in today's generation. At the end of this video, you are going to describe how Bohr model of the atom improved Rutherford's atomic model. So, please keep on watching and join me to the history of atoms. Before we start, let us have a very short game called Jumble. I will be showing pictures and try to arrange the jumbled letters to form a word. So, without further ado, let's start this game. First word. What can you say about this word? This is matter. That is right. Anything that has mass and occupies space is called matter. Let us have the second one. This is atom. It is the smallest unit of matter and the building blocks of matter. That is atom. Next. What is this word? This is protons. These are the positively charged particles. How about the fourth one? This word is electrons. That is right. These are the negatively charged particles. Let us have the last one. This is neutrons. That is correct. These are the uncharged particles, neither positive nor negative. They were discovered by James Chadwick in 1932. So that's it, class. You did awesome. Did you refresh some of your stock knowledge about chemistry? Alright, now let us continue. Now let us have some trivia. He is Eugen Goldstein. He discovered the idea about the positively charged particle called proton. Amazing, right? Now, let us proceed to the history of atomic theory. Let us start. History of atoms. Again, atom is the smallest particle of an element, the smallest amount of a substance that can take part in any chemical reaction. Let us have the first person who began to search for a description of matter, and he is Democritus. He named the smallest piece of matter called atomos, meaning not to be cut. And this is his atomic model. They were small, hard particles that were all made of the same material but were different shapes and sizes. This piece is indivisible. So take a look of his atomic model. Next is John Dalton. In the early 1800s, John Dalton, an English chemist, performed a number of experiments that eventually led to the acceptance of the idea of atoms. He deduced that all elements are composed of atoms. And this is his atomic model. As you can see, atoms of the same element are exactly alike. According to him, atoms of different elements are different. Compounds are formed by the joining of atoms of two or more elements. So this is John Dalton's atomic model. Next, Joseph John Thomson. In 1897, J.J. Thomson, an English scientist, provided the first hint that an atom is made of even smaller particles. Additional information: he introduced the idea about the negatively charged particle called electrons. His model is also known as the plum pudding atomic model. According to him, atoms were made from positively charged substance with negatively charged electrons scattered about, like raisins in a pudding. That is why it is also known as the plum pudding atomic model. Next, let us have Ernest Rutherford. In 1908, Ernest Rutherford, an English physicist, was hand at work on an experiment. He reasoned that all atoms are positively charged particles were contained in the nucleus. As you can see, all the protons were contained in the nucleus, while the electrons were scattered. They were all scattered outside the nucleus around the atom's edge. So this is the Ernest Rutherford atomic model. Next, Niels Bohr. In 1913, Niels Bohr, a Danish scientist, proposed an improvement. And this is his atomic model. He placed each electron in an specific energy level. Electrons move in definite orbits around the nucleus, much like planet circles the sun or our solar system. These orbits or energy levels are located at certain distances from the nucleus. So this is his atomic model. Now, let us proceed to Arnold Sommerfeld. He is a brilliant physicist, modified Niels Bohr's atomic theory to include elliptical orbits. This is Arnold Sommerfeld's atomic model. According to him, electrons are moving around the nucleus. Assume that orbits doesn't have to be spherical, but can also be elliptical. And this is the most popular image of atom nowadays. And the last one, he is Erwin Schrödinger. He is a physicist and a biologist, and was considered the father of quantum mechanics. Today's atomic model is based on the principles of wave mechanics. According to him, electrons do not move around an atom in a definite path like the planets around the sun. Take a look of his atomic model. According to him, a space in which electrons are likely to be found. Electrons whirl about the nucleus billions of times in 1 second. They are not moving around in random patterns. Location of electrons depends upon how much energy the electron has. And that is how atoms were developed and evolved throughout the years. I hope you learned something new today about the history of atoms. Thank you so much for watching. Do not forget to like, share, and subscribe. Bye!